Hi, my name is Brandon Williams from Edison, and today we are going to look at the Schneider Electric XW Plus inverter and charge controller configured in a grid-tie battery backup application. Let's learn about the Schneider Electric solar inverter and charge controller. The Conext XW Plus is a modular building block sine wave inverter charger that can be used for residential and commercial battery-based, off-grid, grid backup, and grid interactive applications. The Conext XW Plus inverter charger is a self-contained DC to AC inverter, a battery charger, and integrated AC transfer switch. It is configurable in a hybrid system to operate with generators and renewable energy sources. These configurations are capable of extending battery-based off-grid and backup autonomy. Performance highlights: excellent load starting with high 30-minute and 5-second power. This is the surge rating. Off-grid AC coupling with PV inverters using frequency power curtailment method, also known as frequency shifting. Operation in hot environments, up to 70 degrees C. That's hot. Conversion of DC energy to AC energy for export to the utility grid. Selling back. Rolling that meter back. Power factor corrected charging minimizes AC current required for charging. True sine wave output. Distinguishing features. Grid interactive feature set enables time management and prioritization of energy sources and power conversion to support advanced modes of operation, such as load shifting, self-consumption, and peak load shaving. Dual AC input connections with 60 amp automatic transfer switch. This is built in, integrates both utility grid and generator. The generator support functionality assists small generators with heavy loads. Auxiliary port assist with relay switching of external devices such as battery room fans, diversion loads, and generators. Configurable battery parameters for customized battery charging. Field serviceable circuit boards and components. The ZAN bus network communication protocol. The Conext XW Plus inverter charger uses ZAN bus, a network communication protocol developed by Schneider to communicate with other ZAN bus enabled devices. You can configure and monitor the Conext XW Plus and other ZAN bus enabled devices in the system using the Conext System Control Panel or Conext CommBox. Also, I'd recommend the new Conext Gateway. It's the next version and a nice update to the CommBox. Again, that's the new Schneider Gateway. Here's the list of all the different accessories. Power distribution panel. It's very important. Power distribution panel without AC breakers. The conduit box. The connection kit for inverter number 2. And another kit for inverter number 3. The system control panel. Automatic generator start module, MPPT 60 amp 150 volt solar charge controller, the MPPT 80 amp 600 volt solar charge controller, the CommBox, like to add the gateway here as well, the battery monitor kit, the power distribution panel 120 240 volt 60 amp breaker kit, and the 3-phase breaker kit. Operation. Bidirectional theory of operation. The Conext XW Plus is a grid-forming device consisting of a bidirectional inverter charger. It is capable of inverting DC power into AC power and controlling the voltage and frequency of its inverter output. It will power external loads attached to AC output. See Figure 1-2. Inverting of DC to AC connected to AC output on page 1-4. The The Conext XW Plus is also capable of charging external batteries by converting AC power into DC power. Figure 1-3, charging external batteries and supplying AC output with AC pass-through coming from AC1 input grid on page 1-5. The Conext XW Plus inverter charger accepts AC power through connection AC number 2 for charging batteries, usually from a generator. Again, see figure 1-4, charging batteries and supplying AC output with AC pass-through from AC2 generator. Essentially here, this inverter allows you to run the grid to the generator, the grid to the inverter, or a generator to the inverter. Either source can be used for battery charging. Either source can be used to pass through and keep the loads powered up if the battery is low. And you have the ability to go in and manually turn on and off that charging capability. For example, if you don't want to charge from the grid, if you just want to use the grid to keep the system operational when the battery is low. That's a good way to minimize AC input, but maximize system reliability. The Conext XW Plus inverter charger will convert externally sourced DC power, solar, battery, even wind and hydro, into AC power for export to the utility grid, back out of its AC1 connection. See figure 1-5, converting excess available DC power for export to the utility grid, AC1 and AC out on page 1-6. The Conext XW Plus has an internal automatic transfer switch, K1, K2, which allows either AC1 or AC2 to be connected to the inverter input, but not both at the same time. See figure 1-1, connection points and major power conversion components of the XW Plus on page 1-4. This allows shared AC energy during charging to directly pass through the inverter from AC1 or AC2, passing through directly to the AC output. Through firmware control over power conversion and the management of K1 and K2, Conext XW Plus can facilitate advanced interaction with the utility grid to optimize the utilization of renewable and non-renewable energy sources. Because the Conext XW Plus is a device capable of forming an AC grid signal, the AC voltage, 120 volts, 2 legs, and frequency at 60 hertz, it is also ideal for use off-grid. The red arrows in the diagrams below represent the direction of power flow in the respective modes of operation. These modes and other special functions will be explained throughout this manual. Very exciting. AC1, AC2 inputs are controlled by the relays K1 and K2 that would either allow the inverter to pass energy through by inverting, or to simply pass through from AC input to AC output. This is AC coming in. Here's the AC interface board, AC transformer, and then the bidirectional AC-DC power block, so the battery would be connected down here. The loads would be connected over here. The grid or gen would be connected over here. Inverting of DC to AC connected to AC output. This right here is the most basic theory of operation for an inverter charger. The DC source is going to come in, be converted by the internal transformer, and power normal plugs, outlets, lights, anything that's normally powered by the grid can be powered by DC, solar, and battery through the inverter on the AC output port. In this diagram, we're seeing charging external batteries and supplying the AC out with AC pass-through from AC1 grid. In this diagram, you can see AC1, the grid is coming in, and is simply passing right through the inverter. Like an internal transfer switch, this is all built into the inverter. No need for another secondary external transfer device. Here, we're charging batteries, taking some of that AC power and charging the battery while supplying AC output by passing that grid through the inverter. In this diagram, figure 1-4, we're charging batteries and supplying AC output with pass-through from AC2 generator. So in this scenario, you can see the connection to the grid has disconnected. We're now connected to a running generator coming in on AC2. In this scenario, much like the last, we're converting some of that energy for battery charging. Down here would be the battery. Here would be the transformer for powering, for charging that battery. And then here's the AC output. So at the same time as battery charging, the inverter is going to take some of that generator AC power and simply pass it through to keep everything powered up while the battery's charging. Once the generator turns off, we're going to go back to this operation. Inverting of DC to AC connected to AC output. So again, once that generator stops, we disconnect the grid. See, we're disconnected, no AC input sources. The inverter is powering the load simply based on inverting battery, solar, any other DC input source connected to the bottom of the inverter, giving you grid-like AC output on a protected circuit breaker box. Figure 1-5, converting excess available DC power for export to the utility grid, AC1 and AC out. So now we're getting a little bit more technical, but this is exciting. In this diagram, in figure 1-5, we're seeing DC from the battery come up through the inverter. The inverter is now programmed to sell some of that energy back to the grid and provide power to the protected circuit breaker panel. This is the way it works in my house. I sell a little bit back during the daylight hours. I use a programmable time-based window to stop the selling back at about 3 o'clock in the afternoon to make sure that I have plenty of power to make it through the night. AC pass-through. This is also the scenario I use with my personal system. When my battery is low in the middle of the night, for example, I don't want to buy energy from the grid, so I will simply allow the grid to come in, pass directly through, and keep all of my outlets, my fridge, anything in my house is electrified directly from the grid, and I'm not going to buy electricity in the middle of the night when the sun should come up tomorrow to help charge the battery, and then we'll go back to that. Once the solar comes back, charges up my battery to a specific level, we are back here inverting power from DC to AC output. Again, the grid would be disconnected once that battery is charged back up. If you have any questions about this, please feel free to give me a call. My phone number here at Iron Edison is 720-432-6433. Again, my phone number, ask for Brandon. My number here is 720-432-6433. I'd be happy to talk to you about how we can customize this to fit your specific application. Let's learn a little bit about the surge performance of the Conext XW Plus inverter. Unlike many other inverters, the Conext XW Plus helps stop voltage from sagging dramatically during surge conditions. The Conext XW Plus handles surges of over twice its rated output power, with only a minimal drop in output voltage for limited periods of time. This is helpful when starting an air conditioner or running a well pump, both of which are becoming more and more prevalent in full off-grid systems. Islanding protection. Islanding protection is an essential safety feature that helps reduce harm to those working on the utility grid from a distributed energy source, such as the Conext XW Plus inverter. Islanding protection also helps to prevent loads connected to the Conext XW Plus inverter from being damaged by a fluctuating utility grid input. I've seen this. The Conext XW Plus uses proprietary positive feedback control to achieve anti-islanding operation while maintaining low total harmonic distortion at the grid connection. Default software settings are programmed into each Conext XW Plus inverter at the Schneider Electric factory so that they comply with applicable safety regulations such as IEEE 1547 and UL 1741 in North America. In some instances, it may be desirable from both a utility and a customer point of view to adjust the default anti-islanding settings. I've done this. For example, the Conext XW Plus may experience nuisance trips if the grid is weak and the voltage falls outside the allowable range specified by regulations. It may be difficult for a utility to adjust the grid to stop this problem. With permission from the utility, the factory settings may be changed to allow the Conext XW Plus to operate over a wider grid voltage range. These settings must only be changed by a qualified service personnel using a special software application, the Conext Config tool, provided by the manufacturer. I own one of these tools. It's a $600 USB connector, and if you need help configuring your system to meet these specific needs, please give me a call. We have a rental program available for this configuration tool. We send it out to your location, and we work with a remote desktop computer program to log in as if we were on site, make these adjustments to your inverter charger, and then you can log out and remove the software from your computer, and it's like we were never there. While exporting energy, the Conext XW Plus continuously monitors the utility grid voltage and frequency. If the grid voltage or frequency move beyond the Conext XW Plus inverter's default ranges, for example during a surge or outage, the inverter stops exporting energy through AC1, that's the grid input, and disconnects from the utility. If disconnected due to a grid voltage disturbance, 5 minutes is the non-adjustable minimum reconnect time during which the Conext XW Plus does not export energy through the AC1 to the grid. The fault light on the Conext XW Plus information panel will indicate a utility fault. Helpful. No fault code appears on the 3-character display because the fault is with the utility grid, not the Conext XW Plus. In addition to the information panel, the Conext System Control Panel, or SCP, indicates a utility fault with the fault light and also displays a fault message on the screen. Faults F23 to F40 are utility faults. See Figure 4.6 fault messages on page 419. The fault cannot be manually cleared. Utility faults will clear automatically when the utility grid voltage and frequency return to within the ranges programmed into the Conext XW Plus inverter. If grid support is enabled and the utility voltage and frequency come back within tolerance, the Conext XW Plus information panel displays a countdown timer for 5 minutes, 300 seconds actually, until the Conext XW Plus can start interacting with the grid again. For linesperson safety, we just don't want to interact with the grid if it's out of range. Basically, when the grid drops off and somebody's out there wrenching on the wires, We just don't want to start selling power back, nor do we want to put AC output power back onto the grid. You don't want to power up your neighbors, and you don't want to power up the grid with your battery system. So that anti-islanding is a very important feature not to be engineered around. AC coupling. Off-grid AC coupled system architecture is often used to create a standalone grid. Commonly, this means that PV inverters, solar inverters, are connected to the output of a battery-based inverter charger, putting both the solar inverter and the battery inverter on the same AC bus, along with the house AC loads. In this scenario, the battery-powered inverter charger provides the necessary frequency and voltage to enable the PV inverter to produce power. This type of system must be able to maintain power generation in balance with power consumption at all times. If there is more power being generated than can be consumed by the loads, power will flow to the inverter charger and be converted to DC power, which flows into the battery. Once the battery reaches capacity, power generation by the solar PV inverter must be curtailed or slowed down to maintain the balance between solar generation and electrical consumption. As the battery bank reaches capacity, the Conext XW Plus battery inverter curtails or slows solar PV inverter generation by raising the AC line frequency, causing the solar PV inverter, to reduce their power output in an orderly manner. This is called active frequency shift power curtailment. During a grid outage, even a home with a grid-tied PV inverter system will be without power because PV inverters, so solar PV inverters, cannot produce power without the presence of a reference voltage and frequency. This is to protect those lines people. It's not going to make power. The solar inverter is not going to make power if the grid is not present. To enable the PV inverter to provide power during a grid outage, the Conext XW Plus is retrofitted in front of the PV inverter, meaning in between the grid and the solar. The PV inverter is rewired from the grid to a critical load or sub-panel, as we say. The sub-panel and the AC couple is on the Conext XW Plus AC output port. When the grid is present, the PV inverter power feeds the loads, and any excess is exported by the Conext XW Plus to the grid using AC1, where permitted by the local utility, of course. During a grid outage, the Conext XW Plus anti-islanding protection prevents power from being exported to the grid on AC1. Conext XW Plus then uses active frequency shift power curtailment to reduce the power output of compatible PV inverters, maintaining the balance of generation and consumption. Got to make sure those PV inverters are compatible. Multi-unit operation. Up to 3 Conext XW Plus units can be installed together in a single-phase configuration with the Conext power distribution panel. A maximum of 4 Conext XW Plus units can be installed together in a single-phase configuration with the addition of a second PDP. The PDP is an ideal optional companion for managing AC connections and integrating a battery bank and other DC connections. Regardless of how it is installed, the maximum number of XW Plus in single-phase or split-phase configuration is 4. 3 XW Plus units can also be configured in a cluster for 3-phase operation using a single PDP. Up to 4 clusters of 3 Conext XW Plus units can be installed in a 3-phase configuration when using an external AC contactor. This is exciting stuff. I've done a system like this and it is beautiful. Multiple Conext XW Plus units and other ZAN bus devices with common connections to battery banks, PV arrays, and the utility grid or a generator require programming during commissioning to enable correct operation. For multiple units, the master Conext XW Plus synchronizes operation of all other connected units using the same ZAN bus network. When AC loads are present, all units produce power, effectively sharing the load. Multiple units do not produce power together when search mode is enabled. See using search mode on page 3-9. Parallel charging. Multiple Conext XW Plus inverter units on the same ZAN bus network synchronize their charging stages to help provide efficient charging of the battery bank. This would be from an AC source like grid or generator. When a single unit transitions from bulk to absorption battery charge stage, so do all other units. In absorption, all the units must complete the absorption stage before any of them transition to the next stage. Note that units stop sharing charge current just before completing the bulk stage and only share charging load during the bulk stage. Each Conext XW Plus unit provides the maximum charging current set by the max charge rate setting. The maximum current may be decreased, subject to the internal operating temperature. Also subject to our programming. When one or more Conext solar charge controllers are installed and operating in the system, Conext XW Plus units synchronize only their bulk charging stage with other charge controllers. Note, lead-acid battery equalization is device-specific. Only the devices on which equalization was initiated will perform the equalization. Other devices will stay in float or no float depending on their settings. AC transfer. When multiple Conext XW Plus inverter units monitor each other to determine the quality of AC input. If AC input is deemed to be bad by any of the parallel units, no transfer to AC out occurs, and the AC LED continues to flash on each unit's information panel until the AC is qualified by all. If the system was in pass-through and the AC fails on any unit, all units transfer to invert simultaneously. Faults. When the Conext XW Plus detects a fault condition, the fault is displayed on the Conext XW Plus. The Conext XW Plus also turns on the fault light in the Conext XW Plus and the inverter information panel. A fault affects the operation of the unit. See fault types on 414 for an explanation. When a single Conext XW Plus unit in a multi-unit system has a fault, only the affected device shuts down. When a master or leader unit has an invert mode fault that causes it to stop inverting, it is considered a system-wide fault and all units shut down. Invert mode faults on all follower units only shut down the affected follower unit. All units shut down when there is a battery-related fault, such as battery overtemp or overvoltage. Independent operation of features. Each Conext XW Plus inverter, grid interactive feature, e.g. enhanced grid support, grid cell, load shave, and generator support, operates independently. This enables Conext XW Plus units in a multi-unit system to be configured to perform multiple functions independently and allows greater flexibility in operating the entire system. That's important to know. We're almost done for today. Auxiliary output. Each Conext XW Plus has one programmable 12-volt, 0.25 amp DC auxiliary output that is able to run a small fan or operate an external relay to perform other functions. Examples include remotely starting a 2-wire start generator in cases where the ZAM bus enabled AGS is not used, disconnecting external non-critical loads, or turning on a diversion load for battery voltage regulation. See aux output settings on page 334 for programming parameters. This is an internal transfer relay. The built-in transfer relay is rated for 60 amps. When an external AC source is detected and qualified on either of the AC1 or AC2 inputs, the relay transfers loads from the XW Plus to the external power source. It stops inverting and uses that external AC input, and then, optionally, activates the battery charger. Multi-unit systems of 3 or more require the use of an external contactor to manage the AC bus. The Conext XW Plus design does not allow the K1 and K2 relays to close simultaneously. This design helps stop generator input, AC2, from feeding back to the utility, AC1. Good design. Well, everyone, that concludes the first Read That Fine manual. I'm Brandon Williams from Iron Edison. Thanks for joining me today. Next time we'll read some more of that fine manual and learn some more fun facts about solar and battery inverter installation. Today I learned a couple of really important things that I didn't fully master yet. I thought this was an important note here, independent operation of features, telling me that each of the inverters can be configured independently. So even with the cascade setting enabled, we may find that some features aren't transferring over, and that's not the fault of the software, but rather that's why it's important to read the manual and understand that each of the inverters in a multi-unit system would be programmed independently. Interesting here as well that when parallel charging, all units complete the absorb stage before any of them transition to the next stage, but the solar charge controllers will only synchronize their bulk charge or the termination of the bulk charge. So some really interesting technical notes here about the operation of the inverters and solar charge controllers. Again, I'm Brandon Williams from Iron Edison. Thanks for joining me to learn more about the Conext XW Plus, solar and battery grid interactive inverter charger. Thanks so much.